The strike asset for a call option or a put option doesn't necessarily have to be some amount of cash or some number of dollars. It could instead be a piece of real estate, or it could be some number of shares of stock. It could be anything, really. And when the strike asset is not some amount of dollars, then we say that we're dealing with exchange options. So we can have exchange call options, and we can also have exchange put options. If we have an exchange call option, then we have the right to exchange the strike asset for the underlying asset. Or, said differently, we could say we have the right to give up the strike asset and get the underlying asset. Now, as before, we're using S to denote the underlying asset, but we're now using Q to denote the value of the strike asset. And if that value is less than the value of the underlying asset, then the call option is going to have a payoff of the excess of the value of the underlying asset over the value of the strike asset. Now, if we have a put option, that gives us the right to exchange the underlying asset for the strike asset. So here we would give up the underlying asset and obtain the strike asset. And this is going to have value when the strike asset has a greater value than the underlying asset. And here's the payoff function then for an exchange option that is a put option. When thinking about call and put options, I think it's helpful to remember that the verb applies to the underlying asset. So for example, if we exercise a call, we call the underlying asset to us, that is, we bring it to us. We receive the underlying asset when we exercise a call option, and we give up the strike asset. I oftentimes like to use the words get and give up. So with a call option, we would get the underlying asset, and we would give up the strike asset. Actually, to be a little more specific about that, we have the option to get the underlying asset and give up the strike asset. And of course, we'll only do that if the underlying asset has a value that is greater than the strike asset. Now, with a put option, we put the underlying asset to the option writer, or we're putting it away from us. So we would get or receive the strike asset, and we would give up the underlying asset. Put-call parity for exchange options looks very similar to put-call parity for regular options. But over here we see that we have replaced the present value of the strike price with the prepaid forward price of the strike asset. Let's use this version of put-call parity to consider a couple of different strategies. The first strategy is suggested by the left side of the equation here, and it is that we will buy a call option, that's suggested by this right here, and then we're also going to buy the prepaid forward on the strike asset, and that's suggested by that portion there. So we're just looking at the left side of the equation here, and now let's consider what the payoff to this strategy is going to be. Well, we bought the prepaid forward of the strike asset, so that means that we will in fact have the strike asset at time capital T. Furthermore, because we have that call option, we're going to have the right to give up the strike asset and obtain the underlying asset. And consequently, we're going to wind up then with the maximum of the strike asset and the underlying asset. Because if the strike asset is worth more, we'll just hang on to it and we'll allow the option to expire worthless. But if the underlying asset is worth more, then we'll make use of it and we'll give up the strike asset and obtain the underlying asset. So you can see that the payoff then is going to be the maximum of the two values. Next, let's look on the right side of the equation, and suppose we bought the prepaid forward on the underlying asset, and we also buy the put option, which is the very last part of the equation here over to the right. So if we have the prepaid forward on the underlying asset, we're definitely going to have the underlying asset at time capital T. Well, what does that put option give us? It gives us the right to give up the underlying asset and get the strike asset. So if the underlying asset has a lower value than the strike asset, we will give up the underlying asset and we'll get the strike asset. Once again, our payoff is going to be the maximum of the value of the underlying asset and the value of the strike asset. Here we've rearranged the put-call parity so that it shows us that there's two strategies that produce equal payoffs, and this time the payoff is going to be the minimum of the value of the underlying asset and the value of the strike asset. First, consider the strategy suggested by the left side of the equation. That is that we would purchase the prepaid forward on the strike asset and we would sell the put option. Since we're selling the put option, we're going to be obligated to make good on the payout of the put option. That is, if asked to do so by the owner of the put option, we're going to have to accept the underlying asset and give up the strike asset. So as a result of this strategy, we're going to have the strike asset because we purchased the prepaid forward of the strike, and also we have the obligation to give up the strike asset if desired by the owner of the put option and to accept the underlying asset. And of course that's only going to happen if the strike asset has a greater value than the underlying asset, and so we're going to wind up with the minimum of the two values. Over here on the right, we see we could purchase the prepaid forward of the underlying asset and sell a call option. And since we sell this call option, we're going to be obligated to make good on its payment. That is, we're going to have to accept the strike asset and give up the underlying asset if required to do so by the owner of the call option. Well, since we purchased the prepaid forward of the underlying asset, we're going to have that underlying asset. And then we also have, because we sold this call option, the obligation to give up the underlying asset and accept the strike asset. And so once again, we're going to wind up with the minimum of the two values. A call option can always be described as a put option, and for that matter, a put option can always be described as a call option. All we have to do is switch the underlying asset with the strike asset to turn a call option into a put option. Let's take a look at how that works. A call option with A as its underlying asset and B as its strike asset allows its owner to give up B and get A. Now a put option with B as its underlying asset and A as its strike asset has the same payoff because it allows its owner to get A and give up B. Since both of these options allow their owners to give up B and get A, the values of these two options are equal, and in fact these two options are really the same thing. In this question, we're given some information about a couple of stocks, and we need to determine what the value now is of a claim that would give us the maximum of the values of the two stocks at time 4. Well, one thing I want to point out here is that we have some information here about the dividends that stock 1 pays and a similar description of the dividends that stock 2 pays. And this is really just kind of a fancy way of describing the fact that the dividends are paid continuously, and the dividend yield of stock 1 is 7%, and the dividend yield of stock 2 is 3%. We also have this option down here that allows us to give up a share of stock 1 and get a share of stock 2 at time 4. And when we think about that option, if we combine that with owning a share of stock 1, then that should provide the desired payoff at time 4. The one thing to be careful about is we just want one share of stock at time 4, and therefore we're going to, at time 0, consider the prepaid forward price of stock 1. I think if you want to, you can answer this question without using much in the way of formulas, but in the solution I will show you how you can use the formulas to answer it. We can use a couple of different formulas to answer this question, but let's start off just thinking about how we could answer it using basic principles. Well, if at time 4 I have one share of stock 1 and I also own that option, then I'm sure to have the maximum of the value of stock 1 or stock 2. Because if stock 1 has a higher value, then I'll have stock 1 and the option will be worthless. If stock 2 has a higher value, then I'll simply use my share of stock 1 and trade it in for a share of stock 2, making use of that option that I have. So, one way to answer this question is just to consider the cost of that option, and then also the cost at time 0 to having one share of stock 1 at time 4. And that cost is the prepaid forward price of stock 1. Here's our current stock price for stock 1, and here's its dividend yield, and the prepaid forward contract runs for 4 years. So here's the prepaid forward price then of stock 1. I just add that to the 5, and that gives me the correct answer to this question. Another approach would be to remember that if I have the call option and I also have the prepaid forward price of the strike asset, then the payoff is going to be the maximum of the value of the strike asset and the value of the underlying asset. If the option described in the question is in fact a call option, then what is the strike asset? Well, the strike asset is the thing that we would give up when we have a call option. So one share of stock 1 is the strike asset. And we know that the prepaid forward price of one share of stock 1 is this amount here, and we also know the value of that call option is 5, so we just add them together to answer this question. Alternatively, we could instead think that maybe that option that's described in the question is a put option. And if it's a put option, we're going to make use of this formula here. We know that if we add the value of the put option to the prepaid forward price of the underlying asset, then again we will obtain that same payoff, which is the maximum of the value of the underlying asset and the strike asset. Alright, well now if it's a put option, what is stock 1? Well, we're able to give up stock 1 in order to get a share of stock 2, and therefore stock 1 would be the underlying asset if that option is a put option. Well, the value of the put option is 5, and we can see that we need the prepaid forward price of the underlying asset, and we've calculated that right here, and once again we come up with the correct answer of 118.37. We need to find the value of an exchange option that allows us to give up 12 shares of stock B and get 3 shares of stock A. The first thing I want to point out about this question is that this option is not a currency option, it is an exchange option. I realize that there are currencies involved, and I've included those to make the question look a little bit more confusing. But fundamentally here, we're really just talking about exchanging shares of stock B for shares of stock A. We have this $12.85 option up here, and it gives us the right to give up 1 share of stock A and get 4 shares of stock B. But that's kind of the opposite of what we need, isn't it? Because we're asked to price an option that allows us to give up B and get A. Well, we're still going to be able to answer this question because we'll use the $12.85 option along with put-call parity to find the value of an option that allows its owner to give up B and get A. When we use put-call parity, we're going to need to know the price of stock B, and that may seem difficult because stock B is priced in euros. But we're really not going to have any trouble converting the price of stock B into dollars because we know that the exchange rate is 1.21, so we'll just take that times the 25 to get the price of stock B. When we use the $12.85 option in put-call parity, we'll need to decide, is that option a call or is it a put? And when we make that decision, we're at the same time deciding what the strike asset will be and what the underlying asset is. In this case, I'm going to say that the underlying asset is 4 shares of stock B. Now, does that make that $12.85 option a call option or a put option? Well, let's take a look up here. The option gives us the right to give up 1 share of stock A and get 4 shares of stock B. And remember, I said the underlying asset is 4 shares of stock B. Well, with a call option, you can get the underlying asset. So this is going to be a call option. Of course, it wouldn't really have to be a call option. I could have instead decided that the strike asset would be 4 shares of stock B, and in that case, the $12.85 option would be a put option. Either way would work. But just so you know, the first solution that I'm going to show you is based on the assumption that this option is a call option and the underlying asset is 4 shares of stock B. I said that I was going to use 4 shares of stock B as the underlying asset, and that means 1 share of stock A is the strike asset. 1 share of stock A has a price of 120, but what's the price of 4 shares of stock B? Well, each share of stock B has a price of 25 euros, and each euro is worth $1.21, and we're dealing with 4 shares of stock B, and therefore the price of 4 shares of stock B is $121. Down below here we have our expression for put-call parity. We know that the value of the call option is $12.85, and as I already pointed out, the price of stock A is 120, but we need to find the prepaid forward price of the strike asset, so we take into account the dividend yield of 4%, and of course the time increment is 7 months. The prepaid forward price of the underlying asset is just $121, because stock B does not pay any dividends. And now then we can solve for the value of the put option, and the value of that put option is $9.08 and some change. That put option allows its owner the right to give up 4 shares of stock B and get 1 share of stock A. What we need though is an option that allows us to give up 12 shares of stock B and get 3 shares of stock A. Well, that's just 3 of these put options then, isn't it? So we just multiply 3 times the value of the put option, and that gives us the answer to this question. Alternatively, we could have answered this question by having stock A be the underlying asset and the 4 shares of stock B be the strike asset. And if we did that, we would still use put-call parity, but that $12.85 option would then be a put option. If you're curious to see how that works, I'll let you just read through this solution, but I don't think we'll spend any more time on it. We already got one solution, and as you know, during the exam, one solution is enough. In this question, we have two portfolios. The first portfolio consists of 1 share of stock W and 2 shares of stock X. The second portfolio consists of 1 share of stock Y and 1 share of stock Z. The $12 option described down here allows us to give up 1 share of stock Y and 1 share of stock Z and get 1 share of stock W and 2 shares of stock X. If that option is a call option, that would mean that 1 share of W and 2 shares of stock X is the underlying asset, and 1 share of Y and 1 share of Z is the strike asset. We can treat this $12 option as either a put option or a call option, but in the solution that I'm about to show you, I decided to treat it as a call option. That means then that the underlying asset consists of W and X, and the strike asset consists of Y and Z. Well, now let's take a look at the option that we need to find the price of, and that option we can see is a put option because it gives us the right to get 1 share of stock Y and 1 share of stock Z in exchange for giving up 1 share of stock W and 2 shares of stock X. So with stock Y and stock Z being the strike asset and stock W and the 2 shares of stock X being the underlying asset, this option is a put option. And we're going to be able to make use of put-call parity to find the value of that option. In order to make this problem a little more tractable, let's define a couple of portfolios. Portfolio A consists of 1 share of stock W and 2 shares of stock X. Portfolio B consists of 1 share of stock Y and 1 share of stock Z. That first option then gives its owner the right to give up portfolio B and get portfolio A. Therefore, portfolio A is the underlying asset and portfolio B is the strike asset if we're considering that option to be a call option. And recall that that option has a value of $12. Now we can use put-call parity to find the value of the corresponding put option. So down here I have put-call parity. Remember, we have the value of the call option plus the prepaid forward price of the strike asset is equal to the prepaid forward price of the underlying asset plus the value of the put option. And of course, both the call and the put option have the same underlying asset and the same strike asset. Our next step is to find these prepaid forward prices. The prepaid forward price of portfolio A is equal to the sum of the prepaid forward prices of its components. And 1 share of stock W has a price of 45 and it has a yield of 3%, and therefore its prepaid forward price is this right here. 1 share of stock X has a price of 55 and it has a dividend yield of 0, but we have 2 shares of stock X in portfolio A, and therefore we have 2 times 55 for this portion right here. The prepaid forward price then of portfolio A is shown right here. Now for portfolio B, 1 share of stock Y has a price of 65 and the dividend yield on stock Y is 0. So the prepaid forward price of stock Y is just 65. For stock Z, the price is 80 and the dividend yield is 2%, and so the prepaid forward price is this right here. The prepaid forward price for the entire portfolio is shown right here. Now we have everything we need then to use put-call parity to find the value of the European put option. We know that the price of the European call option is 12. We know that the prepaid forward price of the strike asset is 143.4159, and the prepaid forward price of the underlying asset is 153.67. And now we can solve then for the price of the put option, which is 1.7458. So choice A is the correct answer to this question.